Today's show is sponsored by Datadog, a scalable, full-stack monitoring platform. Datadog synthetic monitoring enables you to detect front-end errors and performance errors by analyzing user sessions and receiving actionable alerts. API tests help you detect and debug user-facing issues in critical endpoints and applications. Build and deploy self-maintaining browser tests to simulate user journeys from global locations. Start proactively monitoring your user experience today with a free 14-day trial of Datadog by visiting datadog.com/frontend-cloudcast. That's datadog.com/frontend-cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive studios here in Raleigh, North Carolina. And it is Aaron for Cloud News this week. A couple really interesting articles that we have here. And of course, as always, links are in the show notes. But if we move on to the first article, the CNCF has released their 2022 annual survey, and it is a monster. Over 2,000 respondents, first of all, as well as bringing in data from Buoyant, Datadog, and Dynatrace. So really, really big sample size. I'm not going to go into the details. Normally, I give a few highlights here. This one is really big. It is definitely worth going and checking out. Certainly recommend it. As a quick side joke, though, I will say this. The CNCF had a question that was, how much technical experience do you have? And the answers were less than 2 years, 2 to 5 years, 6 to 10 years, or more than 10 years. And 20-ish%, 22 to 15%, depending on if you're an end user or not an end user, how you classified yourself, more than 10 years experience. And that just makes me feel really, really, really old. I need definitely another couple categories in there. So I apologize for that, but I did find that kind of interesting and entertaining. Like I said, lots of stats on adoption, what technologies are being used, how much is being used in production, sizes of clusters, a little bit of everything and anything. So definitely go check that out. For our second article, platform engineering continues to get the rounds and get attention and make a little bit of a buzz. Sam Newman did an article, a pretty lengthy article on platform engineering. What is it? How did it come to be? Some of the things that were maybe limitations with Kubernetes back in the day and how it didn't necessarily achieve the vision originally that everyone thought it was, and hence the rise of this platform engineering. And is it platform? Is it platforms, plural? A little bit of really good, insightful reading about the concepts of this. And then based off of that, Adrian Cockcroft did a blog on it as well that is platform engineering teams done right, and really good read. This one has certainly been making the rounds. And in there, Adrian has 4 principles that really any platform engineering team should adhere to. And it is definitely worth reading those. Again, for sake of time, I'm not going to go into all of them right now, but I would highly recommend that you read both of these articles if platform engineering is something that you are interested in. And so with that, I'm going to wrap up Cloud News for this week. Coming up after the break, we have Kyle Weller, head of product over at Onehouse, and we're going to be talking about data lakes, data warehouses, and Apache Hudi.
Are you struggling to keep up with the demands of managing and securing identity in your distributed enterprise IT environment? You're not alone, but don't let it hold you back. With Strata's identity orchestration platform, you can secure all your apps on any cloud with any IDP, so your IT teams will never have to refactor for identity again. Imagine modernizing app identity in minutes instead of months, deploying passwordless on any tricky old app, and achieving business resilience with always-on identity, all from one lightweight and flexible platform. Want to see it in action? Share your identity challenge with us on a discovery call, and we'll hook you up with a complimentary pair of AirPods Pro. Don't miss out. Visit strata.io/cloudcast. That's strata.io/cloudcast.
Today's show is sponsored by How to Fix the Internet, an original podcast from the Electronic Frontier Foundation. Sometimes it can feel like we are moving towards a digital future no one wants, but it doesn't have to be that way. There are choices we can make to create an internet that makes a better future for all of us. In each episode, Cindy Cohn and Jason Kelly invite someone with a vision on how to fix the internet, someone with real solutions on how to move the needle forward towards a better online world. We checked out the Freedom to Tinker episode of How to Fix the Internet, and it was interesting to see how we can learn from open source and lessons from the past to fix future challenges. Search for How to Fix the Internet in your podcast player, and we'll include a link in the show notes. Our thanks to How to Fix the Internet for their support. And we're back, and Aaron, we get a chance, we've said this many times, and oftentimes people are new to the show. They're new, this week or, many weeks. Couple of things that we really love to dig into, not only for you and I, is to get a chance to learn some new topics that, we're not necessarily, deep in expertise in. And then we also love to talk to companies who are new in this space, companies who are new startups. That's always been kind of the foundation of our show. And so today we get to kind of check both those boxes. We get to do both those things today. We're going to dive very, very deep into some new technology that's going to help people build data lakes, do data streaming. So really, we're going to kind of get into data analytics and how to manage all this data coming on from your company. So, man, you're always excited about this stuff. Give me your sense of, what's on your mind.
Yeah, so it was really interesting because, for those that don't know, we record these shows and actually, I will say there's a decent amount of research that the people don't see that goes into all of these, us preparing the show topics. And it's always fun for me to do that portion of it, of, take an hour or 2 hours, however long it takes to kind of start to dig into a topic. And I admit, data lakes, hey, I was kind of familiar with that. And data warehouses, I was kind of familiar with that. And now we're probably going to be talking about data lake houses today. And what is that? And what does that mean? And it was just a fascinating deep dive into the tech today.
Yeah, the area has expanded tremendously. So really, really excited today to have our guest on, Kyle Weller, who is head of product at Onehouse. Kyle, welcome to the show. Great to have you on.
Hey, thanks so much, Aaron and Brian. It's great to be here.
Yeah. So we're going to dive a little bit into some background, but first and foremost, give us a little bit about your background. Obviously, you've been in this space for quite a while, but not only some of your background, but then where do you focus your efforts on Onehouse? You guys are now a little over a year old. Just took a $25 million round of funding, so congratulations on that. But give us a little of your background, and then where do you focus your efforts these days?
Yeah, great. Thanks. I can share an intro background and then also some of the motivations that brought me to Onehouse tells the story of what I focus on here. So I've been in the data space about 10 years myself. Most of that time was spent at Microsoft, and I started out building large scale data platforms for global services, things like Office, things like the Microsoft search engine Bing. I listened to one of your shows previously. You talked about the Microsoft revolution, and I found some of those interesting as well. And then Cortana was another product that I built data platforms for. Then I switched to building data products itself. I was in the Azure Machine Learning organization and built a cool product that lets you put R and Python code inside your SQL Server runtimes, which was new, that never been done before. And then most recently, I was a product lead for Azure Databricks. If folks listening don't know, Microsoft and Databricks struck up a partnership near 2017, 2018. And we took the Databricks product and we launched it as a first-party Microsoft service on Azure. That was really exciting. I was there when we first launched the service. It was quickly the fastest growing, most popular data analytics service on Azure. And it was an incredible ride. So I was there in the front lines of this emergence of the term. I heard on your intro mention the term Lakehouse. So we can get into that a little bit later. But what I started to notice is that building data lakes and building this architectural pattern like the Lakehouse was kind of a DIY experience. And while the tools, technologies, all these things, they're emerging, they're great. They help you unlock like new solutions and reach untapped data that you have. It's still was an arduous process to build these systems and operate these systems. And so I bumped into the founder or the creator of Apache Hudi, and he was looking to build a new company, which today is Onehouse. And Apache Hudi is really similar to a core technology that Databricks has called Delta Lake. And so I met him and learned about what the project was about. And then the thing that caught my eye was how the vision of Onehouse, we wanted to make it easy to operationalize data lakes, easy to stand up data lakes. And so that's what I focus on here at Onehouse is how can we help people that want to build a data lake get it done in minutes, rather than it usually takes 3 to 6 engineers, like 6 months to a year to build these kind of systems. And I've seen it time and time again. I work with hundreds of customers to build these systems, and we're building a service that can get it done in minutes with a few clicks. So that's what I'm really excited for. Hopefully it can help a lot more people adopt the data lake, adopt a lakehouse type architecture pattern, and then they can use our product complementary to other services like Databricks and EMR or Athena, any of the other query engines that are out there on the data lake.
Nice, fantastic. And I think a good place to start is let's dive into Hudi a little bit. So first of all, before I get into that, y'all raised a very nice Series A round, actually yesterday, as we're recording this. So $25 million Series A. So first of all, congrats on that. Getting funding in these economy and this climate is difficult at best.
Yes.
And so
much different situation from last year. Yes.
And so, but if we look at Apache Hudi, and you really start to dig into its evolution and the problem it's solving and how it came about, it also was a little bit of like, well, yeah, of course, you guys are going to get funding on something like this. So tell everyone a little bit about why Hudi, right? Like, why not just a data lake? Why not just a data warehouse and this concept of a lake house? And tell everyone the background that kind of drove this project and what kind of problems is it solving?
Great. Yeah, I can talk a little bit about the origin story of Apache Hudi and its motivations to get to where it was today. This was created by our founder and CEO at Onehouse here. His name is Vinod Chandar. He was an employee at Uber during Uber's hyper growth phase. And Uber's data system at the time, they had very large deployment of Vertica, which is a data warehouse. And this data warehouse during their hyper growth phase, you can imagine the amount of data that Uber was processing was incredibly large, and their systems were failing to scale. They were becoming very costly. They needed alternatives. They needed to grow out of their deployments that they had, and so the next best alternative that they looked to was a data lake. In the 2016 era, data lakes emerged around the growth of search engines and social media giants. And then, at this time, data lakes were a little bit more mature, but some of the gaps that existed, especially coming from a data warehouse environment to a data lake, some of the gaps that are really obvious there, the data lakes are like immutable file stores. It's a collection of files, and these files are immutable. You can't edit the files. So what happens when, in this world in 2016 and beyond GDPR, someone requests a delete of their information to Uber, right? If you have this data on a lake with immutable file stores, it's very challenging to delete that record, delete that data of an individual. Or also you think about the type of workloads that must have been present there at Uber, a lot of these being transactional in nature, about data changing, not just about new data flowing in, but about, hey, a rider or a driver's location changing in near real time, right? Also, it's very hard to process transactions on a data lake. And so some of these core concepts of transactionality, concurrency control, these different factors didn't exist on the lake, and that's where Vinod created the first of these projects to solve these issues. So they did that. They were able to unlock and build on the data lake. they brought their processing times from like over 24 hours. I can't remember the exact statistic, but it used to take them over 24 hours to process this data to be able to use for their like people that operated the cities in Uber, and decided and made calls on like how they deployed drivers and everything else. It used to take them over 24 hours, and now they could get it done with Apache Hudi in, about 10 minutes, 15 minutes kind of latencies, which was incredible.
Interesting. So, and we've mentioned this before to folks. One of the challenges, one of the things that we love about having new companies and new technologies on the show is we get to introduce a lot of people to them. Sometimes these technologies are fairly robust. There's a lot involved with them. So we did put a bunch of things in the show notes. So as anybody's listening to this and you're going, okay, cool, Ryan's diving into this, I want to be able to do it. There's a bunch of things in the show notes for that as well. Ryan, I want to ask, we're going to dive a little deeper into Hudi. But as Aaron and I were sort of looking through there, there's a bunch of terminology that's sort of new, at least for those of us that don't, live in sort of the data lake world all the time, or the data warehouse world. Things like Delta Lakes, Lakehouses, Icebergs. Like, help us sort of connect the dots with all of these sort of water metaphors. Like, what do they all mean?
Yes.
Like, how do they connect together? Yeah.
Yes, great. Yes, the water metaphors. Everyone loves to poke fun at them. And the one I was just thinking about the other day is this concept of you build data lakes inside of buckets in cloud storage. So cloud storage, like S3, you call them buckets.
Right.
And so we're building these giant lakes, like you might see inside of a quote unquote bucket. I like the metaphors there. But yes, data lakes have been around for a long time. This concept of a lake house is fairly new. And what it means is it's trying to represent a merge of the best capabilities of a data lake and a data warehouse. So that's where that term comes from, lake and warehouse, and you have lakehouse.
And if somebody said, what are the best attributes of those? What are those best attributes?
Yes, the best attributes about a data warehouse that are not present on a lake that you can unlock with a lakehouse. Some of those are transaction support, schema enforcement. Like I mentioned, this is just a collection of files on like an S3 ADLS GCS storage. So you can get schema enforcement and table representations in a lakehouse. You want to be able to unlock BI support. And what I mean by this is like a traditional data analyst be able to run simple SQL queries and be able to have good performance on top of their data lakes with BI support. You can have this, a lakehouse is supposed to be open, and it is designed to help you get flexibility in how you piece together different tools and technologies and query engines. And so that's one core tenet of a lakehouse, where if you build a data warehouse, it's usually more like a silo, and you're kind of locked to the vendor's decision of which tools they allow into the system.
Got you. Okay, that's super helpful. Yeah, absolutely. And for me, it was really interesting for like, okay, yeah, data lake is like just a big blob of data, but getting stuff out of that big blob of data may be hard. And so that's where data warehouse came in. But then I would imagine you're doing some kind of, I don't want to say data migration, but data syncing between the two. And so then you could have data drift or some of these other things of how often things. So then you have this idea of a data lakehouse that combines the two of them, because at the end of the day, it's one less time you're touching the data, and then you have hopefully the best of both worlds.
That's right. You want a single source of truth. Yes.
Got you. Fantastic. Well, and so I'm going to take this one step further then. So Hudi itself really seems to be the focus is streaming data lakes. And so, data streaming in all the time. And I know there's different kinds of data lakes, or when, data gets input into them, but tell me a little bit more. Uber is certainly a good example, but what kind of applications, go into these streaming data lakes, and when does the transactions come into play? And like, tell us a little bit more about like the capabilities both in and out of something.
Yeah, great. Thanks for teeing up the question. And I would say that Apache Hudi has unique differentiators and strengths that make it ideal and the best solution out there on the market today for streaming type workloads when in comparison to the other top 3 projects that are out there, Delta Lake and Iceberg. But I wouldn't say that Apache Hudi's only focuses on streaming, so I'll just call that out. The reason why it is the best for these type of workloads starts from near its origin. Apache Hudi had built this new type of design where every other system that tries to build transactionality on the lake, they do so in a write mode that's called copy on write. What that means is you take files, and when you apply changes to them, you actually rewrite the file to a new version. And then there's a metadata layer that enforces the ACID transactional guarantees. It tells anyone reading or writing which version of the files to go to. Now, Apache Hudi created this new way to write data that we call merge on read. And merge on read is really great for streaming workloads and low latency workloads because when you first write the data, everyone typically writes in this file format called Parquet file format. And Parquet is a columnar file format. It's designed for really fast queries because when you read data, you're asking with a query, select this data from where, and then in your where clause, you put some predicates, and these predicates turn into like column filters. And so the Parquet file format's really lined up to have fast performant queries. Now it's expensive to write and it's slow to write Parquet files. And so Apache Hudi actually blends this and says, you can store your data in Parquet file formats for your blazing fast queries. But when you're actually writing data, the incoming data first can land in a file format that's called Avro file format. And these are row-based files. And the row-based files are really fast to write, but it's more expensive to read them. So Apache Hudi then additionally adds a service alongside that you can fine tune and decide like its frequency and schedule. But it will go then and allow you to get really fast writes. And then at the intervals that you choose, it will then compact that data back into columnar files. So you can get the best of both worlds, really fast writing, but then performant reads when you need them. So it's a really great balancing act. And it can, like I've seen plenty of customers when they go from that copy on write mode to a merge on read, wow, they can make their data systems much faster. And even the CPU and resource utilization will go down.
Yeah, and that to me, from having seen different systems over the years, that always feels like the trade-off is what's the core aspect of the engine, and then as you're trying to add other things, whether it's transactions or SQL queries or other integrations, like what trade-offs are you kind of giving up and so forth. It's always interesting to kind of look at the pros and cons. You actually have a really good chart I was looking at on the website here a couple of days ago that kind of walks through what those pros and cons are. Aaron and I we've been around the open source world for a long time. Stitching together open source projects or platforms can be complicated. You mentioned just in the intro, like it's not unusual for folks to take multiple engineers over multiple months to wire up or get a data lake up and running. That's going to be constraining, especially in this economy where we're seeing budgets tightening. We're seeing sometimes less people thrown at stuff. What are some of the things that Onehouse does to sort of simplify that? Obviously, if a line of business person comes to you and you respond back and you go, well, I can get that done in 3 months, 6 months, and then we start working on it, like that's pretty unacceptable. Yeah. What do you guys do to try and simplify all that?
Yeah, great question. So I'll start with, if you look at any of these query engines that exist on Data Lake and, different vendors like Databricks, Starburst, EMR, Athena, any of these, when you look at them, the origin of where they start with the data is the data on S3, the data in GCS ADLS, and they start their queries from there. But how did the data get there in the first place? And some of that is sometimes the hardest battle. And you think about the data and life cycle of journey and where it emerges from. You've got like applications, you've got services. This data has telemetry that's logged and then stored and captured and then brought. This whole process to bring it to the lake is pretty challenging. And so at Onehouse, what we offer is if you have data in event streams, whether these are Kafka, Pulsar, you name it, or you've got data in transactional databases, which that's where like most people have enormous amounts of data close to their line of business applications. So things like Postgres, MySQL, Oracle, any of these like databases, or if you have data in other storage locations, they're usually hard for a data analyst or data scientist to write analytics or analyze the data. These are RDBMS transactional type systems where you can't just like write SQL to. And so we can take your data from any of these sources and with low latency, continuous ingestion pipelines, so, click a couple buttons, define the path definition, your authentication to these systems, and then we will stream the data to you in a data lake, and specifically in an Apache Hudi like Lakehouse style table. And then we will sync this to n number of catalogs that you would like. If you want this with a Glue catalog or a Data Hub catalog, you name it. And then your data is like ready to go. You can open up any of these query engines. If you have a Presto deployment, or you're using Athena, or you want to use Apache Spark or Databricks, now you connect these systems. They look at your catalog and they see, hey, here's a table. And under all that, we did all the heavy lifting to get it to the lake, to keep those tables performant, optimized, organized, and available to you. So it's kind of a self-serve analytics platform.
Very nice. Very nice. That's a fantastic overview. And we're kind of at time here. So I'm going to close out with one final one, because actually I think this is really eye-opening for our listeners. What are some examples of how companies are really using both Onehouse and Hudi today? Because, I mean, there's some pretty significant use cases and some pretty significant customers that people probably use every day and don't realize it.
Yeah, it's really eye-opening when you start to dive in and learn and read. So you can check out Apache Hudi blogs or Onehouse blogs, or I also posted a new product page along with our funding release, and I put some customer stories on side there if you want to go read. I'll start with one really fast about Apache Hudi. The one that I'm blown away with every time I look at it, the scale of ByteDance, the company that makes TikTok, which many of your listeners may or may not use, polarizing app, I guess. But ByteDance, they have crazy amounts of data. They have one single table that's over 400 petabytes in size, 400 petabytes, and they use Apache Hudi to process their data platform that's used for their machine learning algorithms that train and decide which video to show you next on that swipe. And these 400 petabyte tables, they're pumping 100 gigabytes a second of data, throughput. And Apache Hudi was brought into the mix, and they brought their analytics latency from days down to minutes. And in the stories, they tell you can go read about it, even like 70% CPU savings overall. So a lot of cost reduction, a lot of speed gain up with Apache Hudi, incredible scale. Of course, Onehouse, we're a newer company. We work with large enterprises, but we also work with startups. And you'll see on our product page, if you read some of these, there's quite a variety of use cases. People doing full change data capture from services like MySQL, building real-time machine learning pipelines, replacing long batch processing times, kind of what similar to the ByteDance story. And then even if you're ingesting clickstream data, you have some mobile app and you're capturing data, then you can process all the click streams down on through. And our customers today with Onehouse, they're connecting to other systems, because we don't build a query engine ourselves, and we do so purposefully so that we don't try to build like a vertical lock-in stack. And our customers are using things like Athena, Spark, BigQuery, Presto, StarRocks. There's a whole collection of services that we can help connect your data to make it analytics ready.
Yeah, no, and it looks like you guys also do a bunch of integrations with Databricks and Snowflake, and which has become pretty commonplace in almost every big company these days. So yeah, exciting stuff. Kyle, as we mentioned, we could probably go into a lot of depth with this stuff, go much longer, but you guys are obviously the sort of the best source of diving into this. What's the best way if people want to reach out to you, want to reach out to the Onehouse team, or even just kind of get engaged around the Hudi community? What are good ways to engage with you guys?
Yes, you can reach out to me personally at my email, kyle@onehouse.ai, or you can come through our homepage at onehouse.ai, and there's ways to connect there. You can find me on LinkedIn. And also the Apache Hudi community is really rich. Find us on Slack, GitHub, Twitter. We're around and we're happy to talk about data lakes, lakehouses, data warehouses, any of the above. We love chatting about these type of topics and happy to dive in deeper.
Very, very cool. Very cool. Well, Aaron, we, as we mentioned at the top of the show, we love having new startups. Obviously, it's always exciting to see folks who are, coming out of places like Uber and others who have done this at huge scale, be able to start offering their expertise, in other commercial ways. So exciting stuff. You want to wrap it up and take us home?
Yeah, absolutely. So thank you everyone for listening this week. And Kyle, thank you very much for your time. Super informative. For everyone out there, if you enjoy the show, please leave us a review if possible, wherever you get your podcasts, and also tell a friend. We would greatly appreciate that. If you want to give us feedback, it's always show@thecloudcast.net or on Twitter @thecloudcastnet. And for that, I'm going to wrap it up for this week, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.